Okay, now we're going to question 4. Now, question 4 ikhuluma ngani? Now, question 4 it's talking about quadratic number patterns, right? Lana sikhuluma ngama-quadratic ke manje. Now, before I go to this question, I have to explain what is going on first, right? It's nice to see you, you guys back again. Yeah, let us do now question 4. Now, you're going to go back, right? Now, under the quadratic number patterns, these are the important things that you need to understand. Yabona, if you master these things, like yabona noma ukuthi bangaveza ini, but if you know indaba zakho, ntwana, don't worry, you know you're gonna fly, you're gonna fly, you're gonna fly. Okay, now under quadratic, guys, now the second difference must be constant. And under quadratic number patterns, the second difference must be constant. Now, I'm going to make an example with maybe say, okay, I have 1, I have 3, I have 5, I have 7, right? Remember back when we're doing our linear, right? When we're doing our linear patterns, we had to find our first difference, right? Now, in quadratic, you have to kind of do both, right? You need to find your first difference and you need to find your second difference, right? So now, and then after that, you need to calculate your A, which I'm going to further explain. And then number 3, you need to solve for B and C simultaneously. Now, this is the formula again. The formula for a quadratic number patterns, like from the word quadratic, like you can pick it like as a combo when you're doing quadratic equations, the inequalities, right, where we are solving for x, right? So it's basically something like that. So that's why from the formula you can see that Tn is equals to an squared plus bn plus c. It's almost similar as this one over here, ax. It's almost similar like this one, right? It's almost similar like this one, but now instead of x they used what? They used n, so that's why they call it quadratic number pattern. Okay, now what does a represent in this case? Now a represents half of the second difference. For example, I'm going to do with this example of 1, 3, 5, 7. So now, for example, let's say your second difference, remember the second difference is the one that must be constant, right? Your first difference is you won't have a constant value, right? If your first difference, you have a constant value, which means now that is no longer going to be a quadratic number pattern. That is going to be what? A linear number pattern. So when you if you find, let's say, your second difference utole 4, right, which means your a, you're gonna say half of second difference, which is going to be what? Which is going to be 2. Sometimes you can say, you can use this formula, a is equals to second difference divided by 2. Then you're gonna find your final answer. And then b represents, it is a constant number, right? C, it is a constant number. So you're gonna go to the steps. These are the steps that you need to follow, and trust me guys, before you do any quadratic, and I mean any quadratic equation question, a number pattern, just if you know the steps before you do anything, you must think to yourself, okay, first step, I find FD and SD. Second step, I calculate my A. Third step, I solve for B and C simultaneously, right? Now, I was making an example with this number pattern below, right? Now, let us find our first difference, right? Our first difference is equals to t2 minus t1, so 3 minus 1. In this case, you're gonna get what? You're gonna get a 2. Okay. It's not okay. Now let's say we have this number pattern, right? So we're gonna follow the steps. First steps, we need to find our first difference. So we're going to need to find our first difference. So this is our first difference, right? And then now we need to find our second difference. Now note, on a second difference, this is what we're going to do. We're no longer going to minus the original terms, but you're going to minus now the terms of the first difference, right? So we're going to say 18 minus 12, which is going to give us your answer, which is 6, right? Which is 6. Now this is going to be our second difference. Now I want you to notice in a quadratic name, can you see that our first difference, it kind of makes a linear pattern? I don't know if you can see that. Can you see that it kind of makes a linear pattern, right? Yeah. So can you see the difference here? The difference here is that our first difference here, it is not constant, right? The only thing that is constant is what? Our second difference. Now, then we can go to our formula and then we substitute. We make that what is A? A, it is half of our second difference. What is half of 6? It is going to be 3. So it's going to be 3n squared plus, now B, it is a constant, right? So it's going to be Bn plus C, right? But we're not done. We are not yet done. Now we need to find B, right? Remember, you need to find B and C simultaneously. So what are we going to do? This is what we're going to do. So I'm just kind of going to rub everything here, right? I'm just hoping with the video cool. I don't want it to be very, very long. Now, so since that we have found that, okay, and I rubbed my equation. Okay, there is it. So now, what am I going to do? I'm looking for B, right? So here's what we're going to do. We're going to use the first term and the second term, right? So we're going to start with the first term, right? So wherever I see Tn, I'm going to put 8, right? We are solving for B and C simultaneously. So it's going to be 3. What does n represent? N represents the position. 8 is in which position? Position 1, right? It is the first term, right? And then it's going to be plus, right? So then this one will be what? Will be our equation 1, right? This is going to be our equation 1. Then, like I said, we're going to use two terms. The first two terms, we're now going to use 20, right? So wherever I see Tn, I'm going to put 20. So it's going to be 20, and then it will be 20 minus 3. And then remember, n represents the position. 20 is in what? Position number 2. So I've already transposed it that side, right? So which will be equals to, and then remember n, so it's going to be 2b, because n, we're using the position 2, 1, right? So which will be, right? And then this is going to be what? This is going to be my equation 2. Note, guys, this is one thing, né? We need to continue from here. All right. We need to continue from here, and then I'm going to go a little bit up. Okay, and then now what you're going to do, you're going to subtract now. Now you're going to say, okay, subtract, I'm going to say subtract equation 2, right? Subtract equation 2 with equation 1. So it's going to be 8, right? So it's going to be 8 minus 5 it's equals to 2b minus 2b. Oh, sorry, I forgot something here. Here it was supposed to be 5 is equals to, because since n represents our position, b times 1, it was supposed to be b, right? Because, yeah, it was supposed to be b, then plus c. So it was going to be 2b minus b, right? And then it was going to be plus c minus c. So it's 8 minus 5, it's 3, right? And then we're gonna have 2 minus 1, it's going to be b. Then a positive 1 minus 1, that is equals to 0. So now we have already found b. So b is equals to 3. But now we're going to say that is going to be our what? Equation 3, right? Then what are we going to say? Substitute. We're going to say substitute equation 3 into equation 1, and then which means wherever you see b, you're going to put what? You're going to put 3. So it's going to be 5. Sorry for my 5. So it's going to be 5, and then I see b. What am I going to put? I'm going to put 3. So it's going to be 3 plus c, and then it's going to be 5. Now since it's positive, minus 3 is equals to c, which will be 5 minus 3, it's going to be 2. So my 2 is equals to c. Then I can write my new equation now. So now Tn will be equals to, so it's going to be 3n squared plus 3n plus 2. Then that is our general term. Now, quadratic yona, it is very long, right? And I think this is like 4 or 5 marks, I'm not sure. So yeah, this is how we find our general term. And in most cases they like in exam they like to put a quadratic, right, to marks. So this is how you're going to do it, right? So now we're going to go back now to the questions. I hope this just gave you a brief overview of understanding, right? So now we're going to go back to the question. Now, question 4. Question 4 says, now the quadratic number pattern 4p, 11, q, and 22 has a constant. You see, has a constant second difference of what? Of 1, right? Okay. And then now 4.1 says that show that p is equals to 7 and q is equals to 16. So basically they're asking you to solve for p and solve for q. So I'm going to, first things first, write down your number. Now guys, do not panic, right? Do not panic. Just when I follow the steps. What does the first step say? Find your what? Find your first difference. That's what we're going to do now. Now this is our number pattern, right? Okay, so now, and then what does the second step says? We need to find our second difference. That is what. So what are we going to have? We're going to have so this is going to be the case. So it's going to be 11 minus p. 11 minus p is equals to p minus 4, right? It's going to be equals to p minus 4, and then we're going to have 11. Since it's minus 4 there, it's going to be plus 4. So it's going to be plus 4, and then here it's going to be p, and then since lapho p unjani negative, usebenzisa ngapha uzoba njani? Uzoba positive. Then what is 11 plus 4? It's going to be equals to, it's going to be 15, and then 1 plus 1 is equals to 2p, right? What are we solving here? We're solving for p. So maybe C, is it going to give us the same answer? Let us check. Divide by 2, divide by 2. 2, 4, 6, 8, 10, 12, 14. So it is 7, comma. Guys, we forgot to find our second difference. So here we're supposed to minus, right? So since now, remember that T2 minus T1 is equals to T3 minus T2, that's what we're doing right here. So I took negative 22 plus P plus Q, this one over here, I equated it with what? Negative TQ plus 33 with this one over there. And then I made sure to salang or Q, so here I'm going to divide by negative 1. And then here I'm going to divide by negative 1. Therefore, Q will be equals to, so this is my new equation. But now note what I'm doing. I'm going to say this is going to be my equation. This is going to be my equation 1, right? So I equated these two, right? And then what I'm going to do, I'm going to now equate these two. Now, what am I going to say now? Now, into engizoyenza, I'm going to take negative 22. So ngizothi negative 22. Now, the reason why I'm equating it is because remember what the rule says, right? Remember what the rule says. The rule says that the second difference must be constant, right? Meaning whatever which is here, right? The value here, it is equals to the value here, which is equals to the value here. That's why I equated even in this first step, right? Because the second difference must be what? Must be constant. So I'm going to put 15 minus 2p, right? And then what am I going to do? Now, in this case, I'm going to solve for q. No, I'm going to solve for p. Okay, yazi ngibonile. I saw ukuthi that was going to take us too long. So I think that one was going to take us too long. I'm thinking of let us do it a shorter way. So we're going to take that negative, we're going to take 15 minus 2p. Since now the sentence said has a constant second difference of 1, right? Remember, this is our second difference. So this in basically is equals to 1. So I'm going to say 15 minus 1 is equals to 2p. Is equals to 2p. No, leya bezosisa kwenye into, and the way we can actually do an error. So we didn't want to make an error. So it was going to be 14 is equals to 2p, right? Then we're going to divide by 2, and then we're going to divide by 2. Therefore 7 is equals to p, right? And then wherever you see p, you're going to substitute what? You're going to substitute ke manje ubani or 7. And then you're gonna see that your q is equals to 16. Yeah, no, that the method I was showing you guys, it was going to take long. And then now we move on to 4. Now 4.2, they're wanting the general term of the quadratic pattern, meaning what are we looking for? We're looking for Tn, right? So we found that the constant difference, right? Constant difference, it is what? It is 1. Now, what is half of 1, right? Half of 1 is equals to 0, 0.5. Now, meaning what the formula here will be 1 over 2 n squared, will be 1 over 2 n squared plus bn, right? Plus bn plus c, right? We found our first difference, we found our second difference, right? Which was equals to 1, because they already told us here. And then now we need to solve for B and C simultaneously. We need to solve for B and C simultaneously. We calculated A. It is half of SD. Right. So now, here's what we need to do. Right? We're going to pick two terms. Right? We're going to pick 4 and 7. What to do? So Tn, we're going to put 4. Right? Put 4, and then n, 4 is in what position? It is in position 1, right? All squared, then it will be plus Pn. And then what is n? N is the position, so we're going to multiply p plus 1, which is going to be 1, then we plus by c. Then we're going to transpose, and then that is going to be my equation 1. Then I'm going to move on the second term, which is 7. I do the very same thing. So 7 is in what position? 7 is in the second position. So wherever I see n, I'm going to put 2. Then I do the very same thing. And then this is going to be my new equation 2. Then our next step, we have to what? We are going to subtract equation 2 with equation 1. So we're going to substitute equation 3 into equation 1, right? Equation 3, we saw that 1 comma 5 is equals to p. So I'm going, wherever I see p in equation 1, I'm going to put 1 comma 5. So I'm going to have 1 comma 5. I'm going to have 1 comma 5 plus c, right? Then it's going to be 3 comma 5. We saw that 2 is equals to, our 2 is equals to c, right? Our t is equals to c. Then now we can write our new equation. Can write that now. Tn is equals to, so a was our half, so it's going to be half n squared plus b, so our plate was 1 comma 5, so there's going to be 1 comma 5 n, then it's going to be what? Plus 2. That is our new equation. So now 4.3, they say that determine the value of n if Tn is equals to 23. So here basically they've gave us that Tn is equals to 23. So what are we looking for? We're looking for the position. So now what are we going to have? We're going to have 2, 3, 2 is equals to our formula. Now I hope ukuthi nayibona ke manje. Now since now we are looking for n, it's like now we're looking for x, right? We need to solve this thing in a quadratic way. Basically, what are we going to do? We're going to have to factorize, right? So we're going to have 1 over 2. So what you're going to do, we're going to transpose 132 and make that side be equals to 0, right? And then from here, what are we going to do? We're going to have to factorize now. Then it's going to be, we have to put in 2 sets of brackets. So we're going to put in 2 sets of brackets, right? Then will be equals to, that will be equals to 0. But before we do that, you need to first pick out your highest common factor. You need to pick out your highest common factor before you put into sets of brackets. Can you see what we have our highest common factor, right? So after factorizing, now we're gonna have two answers. We're gonna have n is equals to negative 23 or n is equals to 20. But now n cannot be equals to negative 23 because why? When it comes to position, our position cannot be negative. Like it's the same saying with him. You cannot say that I want to buy negative 3 apples, or I want to go to the negative third shop, right? It just doesn't make sense. So you're going to pick the one that is positive. So n is equals to 20.